Hello and welcome back to another video. Today I'm going to talk about one of my favorite functions of all time. It is the factorial function. Well, it is most famously called the gamma function, which is not exactly the factorial function. It's something pretty close, like gamma of n is equal to n minus 1 factorial. That's it. But I prefer n factorial over gamma n. But gamma has its own uses. Anyways, so what is the factorial function? And why do I like it so much, and why am I talking about it a lot? Well, n factorial is basically defined as n into n minus 1 into n minus 2 all the way up until 1. Alright, so we have this definition. Okay, that seems pretty trivial. A lot of the viewers must have seen it. A lot of you people must have seen it. Use time over time, like 2 factorial is equal to 2 into 1 is equal to 2. 3 factorial is 3 into 2 into 1 is equal to 6. But it's not given as much importance as it should be in many schools. Well, mostly because it's not usually required. It's mostly used in permutation and combination, which comes all the way up until 11th. So, well. Anyway, so why am I talking about it? Well, to give you an idea why this is so cool is because you can actually define pi factorial. It exists, which means it is a real value. This thing is approximately equal to 7.1888. Okay, now how do you interpret this? You can't write pi factorial is equal to pi into pi minus 1 into pi minus 2, because you will never reach pi minus n, for n is any integer, is equal to 1. So how does this happen? How do you interpret this? Well, this is where another one. This is where graphs come in. Well, if you plot any factorial function, well, you have 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial goes all the way to 6, and 4 factorial all the way above that. So if you plot a graph from 1, 2, 3, 4. I'm not going to talk about 0 right now, that will come later in the video. Anyway, so if you plot this graph, you might actually think of it as a straight line. Right. But if you smoothen the edges and actually connect it like a polynomial of some sorts, you will get something like this. Alright. Well, any function can be defined as that to find intermediate terms. Because it can show how a function goes from 1 to 2. You'll find patterns if you keep on arranging the numbers in graphs. You will almost find a graph by knowing values of a separate distance. Like if you take some function, if you know f of 1, f of 3, f of 5, f of 7, and all the odd numbers, like suppose all the way up until 99, you can actually plot it on a graph and predict what f of 50 will be, or f of 50 pi, or f of pi, for example. So that's why graphs come in. They show how a function changes with time. Even though it's an approximate, it kind of does show. Anyway, so if you plot for pi, which is approximately over here 3.14, which all the engineers disagree with, this thing is approximately 7.188. And if you continue it on. Anyway, so what is this equation? What is this value? How do we calculate it? And how do we do this by maths? How do we come to this value? Okay. Well, there's another definition for the factorial which interprets the graph. It is n factorial is equal to integral from 0 to infinity of e to the power minus t into t to the power n dt. Alright. Well, I'm not going to prove this expression, but I'm going to reverse engineer and prove that this expression is equal to n factorial over here. And that, well, for that I'm going to use a method called the DI method or integration by parts. It's basically integration by parts but with shortcut. You will be able to see a video somewhere over here, like on top in the I button. I'll share it. Okay, so how do we prove this? Okay, so by the DI method, well, take a D and an I. Okay, so we have a t to the power n, and t is a polynomial. T is it's like a polynomial function like x to the power n, where n is a constant, so it's a polynomial function. And if you differentiate it, its degree keeps reducing and eventually gets to 1. And derivative of 1 is 0 because 1 is a constant. So we need to keep differentiating this, x to the power n. And if you take e to the power minus t, well, that's pretty nice because derivative of e to the power minus t is minus e to the power minus t, and so goes on. So this is what we want. Well, I'll show you the smaller example to see what we're aiming at and what we want to prove. Let's take 3 factorial is equal to integral of e to the power minus t cube dt from 0 to infinity. And by this method di, we have t to the power n. This is going to be t cube e to the power minus t. Okay, take the derivative, 3t square, 6t, 6 and 0. Minus e to the power minus t, e to the power minus t, minus e to the power minus t, minus and minus. And what's that? T. Alright, now, okay, so this is what we get. So we get t cube e to the power minus t. All the minuses everywhere. Minus, 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 minus. And this is all the terms below this will be 0. So minus t cube e to the power minus t plus 3t square e to the power minus t plus 6t e to the power minus t plus 6 e to the power minus t. Okay, and this is from t is equal to 0 to infinity. Okay, now look at this function. Look at the first term over here. At t is equal to infinity. Well, we know that t cube by e to the power t. These both go to infinity. But we know that as e is an exponential function, e goes to infinity much faster than t goes to infinity. Well, we can apply basic limit over here. Limit t goes to infinity. This goes to a bigger infinity of some sort because this goes faster. So this thing is going to be equal to 0. So for all the infinities, all the terms which have an e to the power minus t will go to 0. And all these terms have e to the power minus t. So infinity will always go to 0. Okay. So that solves one of the things. So minus 0 minus of solving for t is equal to 0. Now all the e to the minus t is equal to 1, so we can ignore that for now. Ignore that. And all the terms with t go to 0 because t to the power n, where n is not equal to 0, is 0. Okay, so all these terms are 0, and this term 6 into e to the power minus t is 6. So this is equal to 6. So that's how we get 3 factorial is equal to 6. That's a rigorous mathematical proof of why 3 factorial has to be equal to 6. Now if you apply similar logic to t to the power n, we'll keep splitting up. And okay, before I get to this proof, I want to show you one more thing. Okay, look at this. We have t cube. T cube goes out, so that gives t, and according to the first derivation, that gives n. And factorial is equal to n minus 1, n minus 2, dot 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 up until 1. So if you get 3 over here, that gives 3 into 2 from the other exponent, n minus 1. So n into n minus 1. And if you have other functions, that this will go from n to n minus 1, n minus 2, n minus 3, because this will keep decreasing by 1 all the way up until it goes to 1, where then it will finally become a constant and then 0. And if you apply similar logic, if you realize, we never really solved for all these terms. We only looked at the final term, where e to the power minus 0 becomes the answer, which we have already seen from this example over here, is going to be the factorial. Now, this method which I've shown, we can see like properly only for natural numbers, because well, we know that these answers are true. We can actually put this definition, which we have known since well maybe 6th or 7th grade, and we know that this is the definition which we have learned. But and so well, this thing shows that this might be correct. This might actually be correct. And not the only good thing. The good thing about this function is that you can calculate this value for n which do not need to be integers or natural numbers. They might even be negative numbers. So the graph which I showed you like this, it might expand in the negative x-axis. Okay, I don't know what this graph is going to look like, but I'm pretty sure it's going to be something cool. Anyways, so like the question which I was talking about earlier, pi factorial is equal to integral of 0 to infinity e to the power negative t to the power pi dt. Okay, this without the limits, I'm pretty sure this thing is unintegratable, but I still need to check. So I'll have to check that on Wolfram Alpha. I'll check it later and write that down in the description below. Okay, and this thing which I've seen from Wolfram Alpha is 7.188 dot dot dot. There are many more 8s caught. Okay, this is pi factorial. Now the question which I was talking about earlier, what is 0 factorial? Remember the graph I didn't write for 0 factorial, because many people might think it is 0, but surprisingly this answer comes out to be 1. Okay, now how do we show that? Well, 0 factorial is equal to integral from 0 to infinity e to the power minus t into t to the power 0 dt. This thing is equal to 1, cut that out. So integral of 0 to infinity e to the power minus t dt is equal to minus e to the power minus t from 0 to infinity. For infinity, this thing goes to 0, and this thing remains. 0 factorial is equal to 1. Okay, this is the comparatively complicated method of proving this. Well, there's another intuitive method which will show you why 0 factorial has to be equal to 1. Okay, now, if you have learned permutation and combinations before, then you must know this formula. NCR is equal to n factorial divided by r factorial into n minus r factorial. Now I'm going to give you a question. Okay, so suppose you have 10 people in a party and you need to choose 10 people among them. In how many ways can you do that? Well, the answer, as you can see, is obvious that there's only one way to choose that. You select all those 10 people. So we can write 10 C10. We know that this is equal to 1 by logical approach. Now if we write it over here, 10 factorial divided by 10 factorial into 10 minus 10 is equal to 0 factorial. Okay, so we'll ignore the middle term. So, and 10 factorial is equal to 10 factorial. These both are not equal to 0, so we can easily cut them out. And now we have 1 is equal to 1 by 0 factorial. And multiply both sides with 0 factorial. And we know that 0 factorial is not equal to 0 because otherwise this won't make any sense. This can't even be in indeterminate form because we have 1 on the numerator. So we get this 0 factorial is equal to 1. And that's the intuitive approach of why 0 factorial is equal to 1. And I hope you understood why n factorial is equal to integral from 0 to infinity of e to the power minus t to the power n dt. Thank you for watching, and please subscribe to my channel if you haven't already, and like, share and comment. Thank you.